Okay, today we're going to talk about completing the square, which is a real handy technique for factoring quadratics when the answers seem pretty hard to do normally, right? Let's say I have something like x squared plus 8x minus 10 equals 0. Now, I could factor this normally, but it seems pretty complex, and I don't think I'm going to have an integer or a whole number solutions. So it already looks pretty tricky to deal with. There's a technique that I can use to make this a whole lot easier, right? I want to transform this side of the equation into a square. And then I'll take the square root, and I'll have just x plus a term, and it'll find my answer. If that doesn't make sense, let me walk you through it. Right? So first thing I'm going to do is I'm going to add 10 to both sides. So I have x squared plus 8x equals 10. And I want this whole side to turn into an x plus something squared, right? I want to have it be x plus a number, let's say b, squared. And then I'll say, equals 10, so I can do square root, x plus b equals square root of 10, subtract b, x equals, and then I have my answer, right? So here's what we're going to do. What do I have to add to both sides? What do I have to add to both sides to make this a square, right? Well, I notice one thing I know about squares is that if I have, let's say x plus b squared, right? If I extend that out, it's going to be x squared plus 2bx plus b squared, right? So this 8x term, and this in our example here is the 2bx squared, 2bx. So I can do some math and I get 4 equals b, right? So I need to add a b squared term to both sides so I can simplify this out. So I need to add 4 squared or 16. I add 16 to both sides, I get x squared plus 8x plus 16 equals 10 plus 16, which is 26, right? I can rewrite that as x plus 4 squared equals 26. I can take the square root of both sides. X plus 4 equals the square root of 26. X equals negative 4 plus square root of 26. An important thing to know, though, is that since I am taking a square root of 26, that means that my answer is actually going to be plus or minus 26, right? For, as an example, if I have something like the square root of 9, right? I know 3 squared equals 9, but negative 3 squared equals 9. So my answer is always going to be positive or negative. And that's an important thing to keep in mind when you're working with square roots. If you're taking the square root of something, you're going to have a positive number as your answer and a negative number as your answer. So you're going to have that plus or minus sign to balance things out. So my final answer is negative 4 plus or minus square root of 26. Let's do some more practice with completing the square so we can really get into it and understand it better. So let's say we have something like this. X squared minus 6x plus 4 equals 0. Again, just looking at it, that seems pretty difficult to factor. We don't have any nice and easy solutions. So we're going to try to complete the square. We're going to try to make this side be a square term, and then get the square root of that using this side, and then subtract the other term that we have to get the answer on this side, right? So to do that, the first thing we're going to do is we're going to remove this term, right? Because we're going to get our square primarily from these two terms, right? We're not going to get it from this one. So we can rewrite that as x squared minus 6x equals negative 4. In this case, we just subtracted 4 from both sides, right? Negative 6 is our negative 6x is a 2bx term, so negative 3 is b. We want to add b squared to both sides, so we're adding 9 to both sides. That means we're going to have x squared minus 6x plus 9 equals negative 4 plus 9, which equals 5. That means we have x minus 3 squared equals 5. We're going to take the square root of both sides. So now we have x equals, sorry, I should probably do the full step. X minus 3 equals plus or minus square root of 5. Right? We add 3 to both sides. We get our answer, our simplified answer, as x equals 3 plus or minus the square root of 5. So our solutions, I guess we can say, are 3 plus the square root of 5 and 3 minus the square root of 5. But that's the same thing as saying plus or minus. So that's how we can complete the square. There's one last thing, though, that you do need to be careful of, and it's always a good way to check your work. Right? We get these solutions, and especially when you're working with square roots, we want to make sure that your solutions are valid. So it's always very important to take them and plug them back into your original equation. So 4 equals 0. Right? So if these work, if I plug in 3 plus the square root of 5 and 3 minus the square root of 5, I should get 0. If I don't get 0, that means it's an extraneous solution, or it's a solution that, yeah, it exists algebraically the way we did it, but doesn't actually exist in the original value, in the original equation, which is important. Because if it doesn't exist in the original equation, if it doesn't get those values in the original equation, it can't work. It's not actually a solution, right? So we can do some math here. That's 9 plus 6 root 5 plus 5. Here I'm just, doing the square method, right? So we know that any, let's say a plus b squared, that's just a squared plus 2ab plus b squared. So I'm just using that kind of quick expansion method out to do there. And then this here, I'm just distributing that 6 out. So I get negative 18 minus 6 root 5, again, all plus 4. I can cancel some terms out straight away. I can also see that, hey, I get 18 minus 18, which does indeed equal 0. So I know 3 plus the square root of 5 works, but I also want to check 3 minus the square root of 5 to see that that works as well, just so I know there's no extraneous solutions and that I am safe. So that's 3 minus the square root of 5 squared minus 6 times 3 minus the square root of 5 plus 4 equals 0. That's 9. Oh, not 9 squared, just 9. 9 minus 6 root 5 plus 5 minus 18 plus 6 root 5 plus 4. That's 18, because these two cancel out, minus 18, which does indeed equal 0. So again, hey, I know it works. So we know that both these solutions work for the original equation, so they are our final answers. And that's us completing the square, right? Now let's just do some practice just completing the square by itself without worrying about terms on the other side. All right? How can we take numbers and rearrange in square form, right? Let's say I have a square, right? X squared plus 26x plus blank. In order for this to be a square, for me to be able to rewrite it as x plus something squared, what does this last term have to be? Well, we know that if we were to expand this out, we get x squared, we do have, plus 2bx plus b squared, right? So we know that these So that this term then is going to be our b squared term. But in order to find b, we just use this term, right? So we can say 26x equals 2bx. We can divide by 2x and get 13 equals b. So that means we're going to add 13 squared, or 169. So in order for this to be a square, it's going to be x squared plus 26x plus 169. That fills the blank. And if we were to rewrite this, that's just x plus b. We know b is 13, so that's x plus 13 squared, right? And that's again another example of completing the square, just using that logic to solve problems. And that, my friends, is how you complete the square. I hope you found it very helpful for doing algebra and solving pretty difficult to factor equations. That's it. I hope you have a great day.